What if everything we call future is someone else's past? Welcome to Information World. We experience time as a straight line. A clear direction. Past behind us. Future ahead of us. We remember yesterday, but not tomorrow. We age forward. We move forward. The universe expands forward. But what if that direction is not universal? What if outside our universe, time moves backward? To understand this idea, we need to start with something very important, the arrow of time. In physics, time has a direction because of something called entropy. Entropy is the measure of disorder. According to the second law of thermodynamics, entropy always increases in a closed system. Things move from order to disorder. Ice melts. Stars burn out. Structures decay. This increase in entropy is what gives time its forward flow. But here is the strange part. The fundamental laws of physics like Newton's laws, electromagnetism, and even many equations in quantum mechanics do not care about direction. They work the same whether time moves forward or backward. If you record two particles colliding and play the video in reverse, the equations still make sense. So why do we experience only one direction? Because our universe started in a very special state, extremely low entropy at the beginning, in the event we call the Big Bang. From that low entropy beginning, disorder has been increasing ever since. That is why time feels like it moves forward. Now imagine this. What if our universe is just one bubble in a much larger reality, sometimes called the multiverse? In some cosmological models, like eternal inflation, universes constantly form like bubbles in a cosmic foam. Each universe may have its own physical constants, its own dimensions, its own laws, and possibly, its own direction of time. Some physicists have proposed a bold idea. Instead of the Big Bang being the absolute beginning, it might have been a kind of mirror point. A central moment where entropy was lowest. From that central point, time could flow in two opposite directions. In our direction, entropy increases forward. In the opposite direction, entropy increases the other way. From the perspective of observers in that opposite universe, their time would feel completely normal. They would see their past behind them and their future ahead of them. They would believe time moves forward just like we do. But from our perspective, their entire timeline would look reversed. Their birth would appear as death. Their creation as destruction. Their expansion as collapse. This is not science fiction. In 2018, physicists Sean Carroll and Jennifer Chen explored models where time could extend in both directions from a low entropy state. In these symmetric time models, the universe does not have a single beginning. Instead, time branches out in two opposite directions. So what would it mean if outside our universe, time moves backward relative to us? First, causality would look inverted. In our universe, causes come before effects. You drop a glass, it shatters. But in a backward time universe relative to us, we might interpret their effects as coming before their causes. But for them, everything would feel perfectly logical. Because within their own timeline, entropy still increases. The arrow of time still points forward, just in the opposite direction compared to ours. Second, communication would be almost impossible. If we tried to send a signal to such a universe, from our point of view, the signal would arrive before we sent it. And their reply would arrive before they decided to respond. The logical paradoxes become overwhelming. The very concept of interaction may break down. Third, the concept of before the Big Bang changes completely. If time moves backward outside our universe, then asking what happened before the Big Bang may not make sense in the way we think. Because before assumes our direction of time. In a larger reality, our forward may simply be one branch of a much larger temporal structure. Now let's go deeper. Some quantum gravity theories suggest that time itself may not be fundamental. In certain interpretations of quantum mechanics, time emerges from more basic relationships between events. It is not a universal ticking clock. It is more like a pattern that appears when systems become complex enough. If time is emergent, then different regions of a greater cosmos could generate time differently. One region's forward could be another region's backward. Think of it like two sides of a mountain. From one side, you walk up. From the other side, someone else also walks up. But to an observer in the sky, one of you appears to move in the opposite direction relative to the other. Neither of you is wrong. You just define up based on your position. There is also a fascinating connection to antimatter. In some interpretations of particle physics, antimatter can mathematically be described as matter moving backward through time. This idea comes from the work of physicist Richard Feynman. While this does not mean antimatter literally travels to the past in our everyday sense, it shows that time reversal is deeply embedded in the equations of nature. If time reversal exists at the microscopic level, perhaps entire regions of reality could express that reversal at cosmic scale. Now imagine the philosophical consequences. If another universe's future corresponds to our past, then what we call the beginning might simply be the middle of something far larger. Maybe reality is not a line. Maybe it is a mirror. Maybe the Big Bang was not an explosion into nothingness, but a pivot point between two temporal directions. And here is the most mind-shaking idea. If time moves backward outside our universe, then the total entropy of the larger system might remain balanced. One side increases in what we call forward. The other increases in the opposite direction. Globally, symmetry is preserved. This could solve one of the deepest puzzles in physics: why did the universe begin in such a low entropy state? Instead of being an unlikely accident, it could be a natural symmetry point. Of course, we must be clear. This idea is still theoretical. We do not yet have experimental evidence of another universe where time flows oppositely. Our observations are limited to the cosmic microwave background, galaxy expansion, and the behavior of matter and energy inside our own cosmic horizon. But physics has taught us something very important. Reality is often stranger than intuition. There was a time when people believed space and time were absolute. Then Einstein showed us with relativity that time slows down near massive objects and at high speeds. Clocks tick differently depending on gravity and motion. Time is flexible. Quantum mechanics then revealed that particles can exist in superpositions, that reality at small scales behaves like probabilities rather than solid objects. If time can bend, stretch, and slow down, is it so impossible that it could also reverse under different cosmic conditions? When we look at black holes, we already see hints of extreme time behavior. Near the event horizon, time dilation becomes so strong that from an outside perspective, falling objects appear to freeze. Our understanding of time breaks down completely at singularities. So maybe, just maybe, the boundary of our universe hides something even more radical. A region where the arrow flips. A cosmic mirror where our future is someone else's ancient history. And if that is true, then time is not a river flowing in one direction. It is a structure far greater than we can perceive. We are simply traveling along one side of it. The question is not just whether time moves backward outside our universe. The deeper question is this: is time itself a local phenomenon, like weather? Something that depends on where you are inside a much bigger reality? If so, then our experience of past and future is not universal truth. It is perspective. And that changes everything. If this idea expanded your mind even a little, imagine what else might be hidden beyond our cosmic horizon. Thank you for watching all the way to the end. If you enjoyed this journey into the mysteries of time and the universe, make sure to like this video and subscribe to Information World for more deep explorations. And I really want to hear your thoughts. Do you think time could move backward somewhere beyond our universe? Tell me in the comments below.